And the question is, decide whether it's a perfect square. If it is, factor it. If it's not, write not a perfect square. So we got to kind of try to figure this out, right? Here's what I would say. Honestly, I'm going to tell you to do something you don't have to do here, but I think it's just a good rule of thumb. Is this in standard form? Is the biggest exponent first? No. Let's go ahead and do that, even though you could actually work this problem without doing it. So n to the fourth, what's the next biggest exponent? That n squared, right? So the next one we have up there is that minus 33 n squared, and then we have the 121. That puts it in standard form, which it's just at this point in your math careers, it's just a good idea to do that. You're going to find out later you don't actually have to. All right, so now, let's remember, the way I'm going to check this is I'm going to say, is first of all, if the first term's a perfect square and the last term's a perfect square, then I can actually think about it. Before I actually do that, though, is there anything that divides out of all those numbers? 3 goes into 9, 3 goes into 33, but 3 doesn't go into 121, does it? Because 3 goes into 120. 3 times 40 is 120. So 121 is not divisible by 3. I can kind of see that. Is this 9 to the fourth? Is it a perfect square? What do you square to get 9? 3. What would you square to get into the fourth? Yeah, it would be n squared. Because remember, I can take this, if you watched any of those videos, one of the ways I know is if I take that 4 and I divide it by 2, what's left would be the thing that would be squared. That's kind of using some exponent rules. Once you get it down, you can see that n squared would be n to the fourth. Let's look at 121. What would you square to get that number on the end, the 121? 11. Now, if this is a perfect, okay, here's another tricky thing on this one. There's a minus sign right here in there. Could I also square negative 11 and get positive 121? What's negative 11 times negative 11? 121. So since there's a minus sign there, I'm probably wanting to think about negative 11 squared here. That's just something I probably need to think about. Now, let's see if this is a perfect square. If it's a perfect square, I should be able to take 3n squared, the thing inside here, and negative 11, the thing over here. I should be able to multiply them and then double them, which means multiply by 2, and that's going to be my middle term if it's a perfect square. Well, 3n squared times negative 11 is what? Negative 33n squared. But when I double that, don't I get negative 66n squared? Is that what's in the middle? I just had the negative 33. You see how they're trying to mess with you there? When you just multiply the 3n squared and the negative 11, there is a negative 33n squared in there, but you got to remember to double it, don't you? Once you get through multiplying this thing and this thing, you have to double them. That's what the middle term's going to be, not just those two numbers multiplied together, but multiply them together and then double it. Oh, it would have had to be minus 66n squared in order to be a perfect square, wouldn't it? So not a perfect square. Almost, right? But almost doesn't cut it here. Wow, what a lot in a problem. You had to put it in standard form. Then you had to look at the first and the last terms to see if they were square roots.
A lot for nothing.
Yeah. And then after you figured out what their square roots were and you rewrote them that way, you had to multiply them and then double them to check the middle term, and then guess what? It didn't work. All that work for nothing. But now you know it's not a perfect square. Why are we doing this? Why do you think they're giving us a hard problem like this before they even tell me how to factor something with a 9 out front? It's because what you're going to find out is the hardest problem for most people to factor are things where the first term has a number out front. It's not just x squared or n to the fourth. Usually it's easy to factor things as long as there's not a number out in front of that first term. So this gives you a way to try to factor some stuff without having to do that very hardest factoring technique that most people hate with a passion. If I were to take a vote on it, okay, so now, do you know how to factor x to the fourth? This is coming up in a future lesson too. You really don't know that so much. There is a way to do this and do the x to the fourth, okay? To do that little x thing that I've done, but I'm not going to use that just because that's not in this section. Let's use what they're trying to get us to learn here. Is this problem, first of all, there's nothing that divides out of all these terms, is there? Always got to check for that GCF first. Can I rewrite this problem as something squared and something else squared for the first and last terms. What do you square to get x to the fourth? Yeah, x squared squared. Hey, yeah, that's good. What do you square to get 16? Ooh, careful, almost 4. Yeah, that's that tricky thing that happens, right? It's just so easy to do that. Okay, now, I could square 4 to get 16. I see there's a negative here. Could I also square negative 4 to get 16? Negative 4 times negative 4 is also a positive 16, isn't it? Okay, so what I'm going to do is I'm going to look at that as a negative, because if I don't, I will not get a negative. When I multiply x squared and just a 4 together, I'd get 4x squared. And when I doubled it, what would it be? 8x squared, but it would be a positive 8x squared. If I want a negative 8x squared, I'm going to have to look at that as a negative 4. I'm going to have to make that little adjustment. Negative 4 times x squared is negative 4x squared. And if I double it, it would be negative 8x squared. This is a perfect square, isn't it? Okay, so how I write it is I say, oh yeah, this worked. It worked when I multiplied negative 4 times x squared and I doubled it, I got negative x squared. So this factors as x squared, and then I have a minus 4 squared. That's the lesson for today that we would have learned from this, that we could actually do that. So far, this is like a normal problem. Now, to keep going forward, though, we have to think about what we learned last time. When I factor 12 into 2 times 6, I still have to keep factoring that 6 down if I were to do a factor tree, right? So here, I got to keep going because it's kind of like that situation where I'm not done. Look inside of there. What do you see? You see a perfect square minus another perfect square, right? So inside of here, we have something squared, and we have minus, and then we have, I'll use purple, something else squared, don't we? What do you square to get x squared? X. What do you square to get 4? 2. So I have a square, but inside of it, it's a difference of 2 squares, and just this part right here factors into, I put an x here and an x here. Then I put this 2 here and this 2 here. And I put a plus on one and I put a minus on the other. But each one of those is squared, because that's just the inside part. If I leave it inside the parentheses, wasn't there still a square on that outside parentheses? Right? Okay? Now, this actually shows up in Algebra 2, Pre-Cal, all that stuff more than you'd think. This actually stuff does kind of happen. You have to kind of keep factoring here. Now, if I have parentheses and there's a square on the parentheses, doesn't the square go with everything in the parentheses? So the square goes with this thing right here, so we do have x plus 2 squared. And the square also goes with this thing, so that becomes x minus 2 squared. And that's what they asked us to do right there, was to show that it's the same thing, okay? So it's like we break it down using today's lesson, and then when we look inside, we can break it down using yesterday's lesson, okay, Tuesday's lesson. But anyway, I need to let you guys go.